So we're going to see how we can use a graph to find a limit of a function. So on our left, we have a graph of our function f of x, and on the right, we're looking for various quantities. First, we have the limit as x approaches 2 of f of x. So first of all, let's identify 2 on the x-axis. And then we need to look towards corresponding function values for that 2, x equals 2. Now we want the limit as x approaches 2. So on the left-hand side of 2, we're looking over here on the left through these x values. As I get closer and closer to 2, we want to know what's happening to our function. So my blue arrow indicates the process of getting closer to 2, or my arrow on the left indicates the process of getting closer to 2. And the black arrow illustrates how the function is behaving. So we can see what's happening to the function values. We can see that they're negative and getting even more negative. So what is happening though is those values are getting closer and closer to the limit. And the limit would correspond to what's happening in a neighborhood right around x equals 2. And so what we can see is that from the left, my function values are decreasing until we get near -3, and then they start to increase. So the limit on the left is -3, and then the question is, does the same thing happen on the right? So we can look at the x-axis to the right of 2, and this arrow on the x-axis on the right illustrates this idea of getting closer and closer to 2. And what we're interested in is how does the function behave through those same x values. And so what we can see happening here is that the function values, again, are getting smaller and smaller and approaching this -3. Now, since I was able to approach 2 from the left and from the right, and those limits from the left and the right approach the same value, then we do have a limit as x approaches 2, and that limit is -3. Now, so then the next thing we're asked to find is what is the function value at x equals 2. So again, finding 2 on our x-axis, we come down and we look for what the corresponding y value or function value is when x equals 2. And we can see here that f of 2 corresponds to this point right here, whose y value is -3. Now let's turn our attention to a different location on the graph. Now we want to know what happens as x approaches 0. So finding 0 on the x-axis is here. And so looking this time upwards to see where on the graph we're going to be looking. Let's first examine what's happening from the left. So from the left, we consider x values negative, increasing towards 0. And we want to examine what happens to the function as those x values increase towards 0. And it appears that those function values are approaching 1. Now let's look on the right, again headed towards 0. So our x values are decreasing towards 0. And again, we want to look at what's happening to the function for those particular x values. And we can see that the function values as we get closer to 0 are actually increasing towards 1. So our limit from the left is 1 and from the right is 1. So we can say that the limit as x approaches 0 of f of x is equal to 1. We're asked to find f of 0. And so again, here was 0, and we're looking to see if there is a corresponding function value. And it appears to be so. There is a point there. And the coordinates of that point are 0, 1. The limit, the value of the function f of 0 equals 1. And now shifting our attention to another location on the graph, we are examining what happens for x equals 4. So again, identifying 4 on the x-axis. We're interested in what's going on with the function as we get close to 4. So taking x values from the left, so increasing towards 4, we look to see what is happening with our graph and the function values. And we can see that these function values are increasing, increasing, increasing until we get near really, really close to 4. So it looks like that limit from the left is equal to 1. Now let's examine what's going on from the right. So my x coordinate values are going to be decreasing towards 4. And we're wondering and paying attention to what's happening to the function as we get closer and closer to 4. And we can see the function values are decreasing as we get closer and closer to 4, and they're decreasing, getting ever so close to 1. So the limit as x approaches 4 of f of x is equal to 1. And then f of 4 we're asked to find. Here's x equals 4. Looking up at our function, is there a point there? Yes, there definitely is. So f of 4 does exist, and f of 4 is equal to 1. So now let's look at a second function. The graph is here on the left, and we've been asked to find these various pieces of information on the right. So first we're asked to find the limit as x approaches negative 2 of f of x. So identifying negative 2 on the x-axis, we're interested in how the function behaves as x gets close or approaches negative 2. So let's start by looking from the left. So our x values are increasing towards negative 2. And what we're curious about is what's happening to the corresponding y values or the function values. So as my x values get closer and closer to negative 2, increasing, notice that our function values are actually decreasing. And it looks like they're decreasing to negative 3. Let's check the right-hand side. So this time our x values are decreasing as we approach negative 2. And what we're interested in is what happens to our function values as those x values decrease towards negative 2. So looking at our graph of our function, we can see that as those x values decrease towards -2, my function is decreasing towards, and it appears to be -3. So we can say, since they both from the left and from the right are approaching -3, we can say that the limit as x approaches -2 of f of x is -3. Next, we're asked to find f of -2. So here's -2 on my x-axis, and I'm looking for that corresponding function value. And it appears that function value does exist, and that the y value, or the function value, is -3. Now we're being asked to consider what's happening as x approaches 2. So here's 2 on our x-axis, and we're investigating what happens as x gets close to 2. So starting from the left, as my x values increase towards +2, what's happening with my y values, or my function values? So it appears that my function values here are increasing as well, and they're increasing, and it appears to be approaching 1. So let's see what happens on the right hand side. This time my x values are decreasing towards +2, and what appears to be happening to my function values is it appears that they are decreasing. The function values are decreasing, and it appears to be approaching 1. So we could say that the limit as x approaches 2 of f of x is 1. Now lastly, we're asked to find f of 2. So here's 2 on my x-axis, and if I look at the graph of my function, I see that there's a hole there. And because there's a hole there, that means that the function does not exist there. So we would say f of 2 does not exist. DNE means does not exist. Not exist. So what this particular pair of questions highlights is that it is possible for a limit to exist as x approaches a particular value. So in this case, as x approaches 2, it's possible for a limit to exist even though the function is not defined at a, or not defined at 2. That limit can still exist. I hope this helps.